There wasn't a really good picture to pull, so there you go. Okay, logs. All right. So a logarithm is an inverse of something that we already know. Every operation that we are aware of mathematically has exactly one inverse operation. Okay? So every operation has exactly one inverse. What would be the inverse of addition? Oh, tricky, tricky. And the inverse of multiplication. Oh, good. What about cubing? A cube root? I'm not sure if you cube rooting, but we'll just call it a cube root. Okay. And the inverse of exponentiation, I like that word, is a logarithm. Okay. It is a logarithm. And that's what our goal is today, just to be able to express things as a logarithm and simplify logarithmic expressions. Okay. So just one learning target today. So here is our exponential form. We have some base to some power a. It equals some value c. In logarithmic form, that's log base b of c equals a. Here's what I need you to remember in terms of relating exponential expressions to logarithmic expressions. A base is a base. Okay? If it's the base of your logarithm, it's the base of your exponential function, and vice versa. If it's the base of your exponential function, it is the base of your logarithm. Okay. And my personal favorite, logarithms equal exponents. Okay. So whatever the exponent is in your exponential expression, hey, I need to take this phone call. Then that is what your logarithm is going to equal, is the exponent in that. Quit. Okay, now. So we're talking about logarithms, between exponential and logarithmic forms, switching between the two. One of the things that one of my students showed me that they thought was really cool, in a logarithm, if you take and you go around, it kind of looks like an E. You make it into an exponential form. So the base is the base. What it's equal to is your exponent, and you pick up the number inside, and it looks like an E. So I had a student show me that one time. So there you go. A common logarithm is a logarithm with a base of 10. Okay, so when we talk about common logs, it's a log with a base of 10. You will not see the base. Okay, so if you're looking at a logarithm and there's no base there for you to see, it's understood to be 10. Okay, so if no base is shown, it's a base of 10. A natural logarithm is a log with a base of e. E was that new Euler's number, all right, the natural number that we talked about last week. They do use a different representation for it. They use ln, all right, for natural log. I don't know if they were just dyslexic or what, okay, but ln, all right. I think it has something to do with the Greek words, and anyway, you can look it up if you want, all right, but it's ln, okay. So the first thing we have to be able to do is to translate it between forms. Okay, can we go from exponential to logarithmic, logarithmic to exponential? So if we look at the next page, all right, let's mess with a few of these, okay? Just rewriting them, all right? We're not solving anything, we're just rewriting. And so if we look at the first one, I'll do a couple with you and let you do a sum. 3 to the second equals 9. What's the base of that expression? 3, okay? So it's going to be log base 3, and I just kind of do it this way. My logarithm always equals my exponent. What's my exponent? 2, and then the other number goes back inside the logarithm, okay? So log base 3 of 9 equals 2. We just rewrite it, okay? Let's do one more together. Okay. What's the base of the exponential expression? 10. So we're going to use a common log. We're not going to put the 10 as the base. All right, it's understood to be there. The logarithm is going to equal the exponent. What's the exponent? X. And then the y goes inside. So log of y equals x. All right. I will not, but you will never see it written that way on anything ACT or AP. Okay. All right. See if you can translate the next two. All right, so for that next one, we'd have log base R of W is equal to T. How'd you do? Okay. And then the last one, they rearranged the order on us, so don't flip out over that. What's the base of that exponential function? E, so we're going to use ln of y is going to equal my exponent, which is 3x. Okay. Well, if we can go from exponential to logarithmic, we got to be able to go from logarithmic back to exponential. All right. So doing so, okay, again, we're not solving. Y'all, if you don't have a friend that just, like, that gets you and you get them, and, you, like, I just pray that you find that person in your life. Like, anyway, sorry. My friend just sent me this text, and I'm about to pee my pants. I'm going to laugh so hard. Okay. She knows exactly what I need when I need it. All right, let's look at this one. So if I rewrite it, my base is 7. What's my exponent going to be? 2. And it equals the number inside, which is x. Okay? Likewise, on the next one, my base is 3. All right. What's my exponent going to be? X. And it equals the y, which is inside. All right? What about the next one? What's my base? 10 to the second would equal y. And the last one, e to the fourth would equal c. So any question about going between forms, okay? Now, AP is not going to ask you a question like that, all right? But if we don't understand that, we can't do what's coming later on in the next few sections, okay? All right, so now let's talk about evaluating expressions involving logarithms. Let's start with non-calculator, okay? Because we'll be asked to do it both, okay? When we're evaluating non-calculator and we're just trying to figure out what a logarithm is equal to, we're trying to find an exponent, all right? That's what we're looking for. What's the exponent that's going to give me that base, all right, equal to the number that's inside, okay? So we're finding an exponent. Now, there will be times when we need to use a calculator. All right. Well, the good news is you have 2 buttons, all right, that cover 2 of our logarithms. All right, so we have buttons for a common log and for an ln. All right there on the home screen next to 7 and 4. Okay, so you just got a plain old button there. All right, if it's a common log or if it's an ln. Now, if it's a log with a different base, there's 2 ways to get there, okay? It's about the same number of keystrokes, all right? But one way to get there is math. And then we're going to choose option A, which is log base, is what it'll say, okay? So you can hit the math button and choose log base, all right? You have to arrow down, or I like to up arrow. It takes me to the bottom of the menu, okay? So math A for log base. Second way to get it, and I really like the shortcuts, but most people choose something else, is alpha window. So that's right there on my screen. And I choose number 5, which is log base. Okay? So those two are the same. All right? They give you the same option. When it comes up on your screen, it looks like this: log, empty space, and you plug the numbers in. Okay? So you can plug in the base and what it's equal to. Either one is fine. All right? Whichever one you can remember in terms of the calculator. Alpha window 5. I've gotten used to using those alpha shortcut keys, and so I'm just used to them. They're my go-to. Even though it's an extra step, like an extra button to push, I don't have to do an up arrow and all of that. So just gotten used to doing that. Okay? But they both work. Right. Okay, well, let's jump in here. Let's do some. Okay, I really like logarithms. It's just exponents. So that makes me feel like I know something. Okay, so if I look at this one, I'm trying to find the exponent 2 to what power gives me 8. It's 3. That logarithm equals 3. Okay, so not terrible. On the next one, 5 to what power gives me 25? 2. Okay, that's what the logarithm equals. So just being able to evaluate those without a calculator, right? The next one, 2 to what power gives me 32? 5. Okay. What's the base on the next one? 10. 10 to what power gives me 100? 2. Okay, so very much arithmetic, all right? Now, just to keep it interesting, let's look at this one. 16 to what power would give me 4? Has to be a half, right? We need a root to make that happen, okay? Square root of 16 is 4. That means my root is 1/2, so that one's a little different. Okay, so know that that can happen. You can't get fractions as answers. And then on the next one, 3 to what power would give me 1? 0. And then I got another common log there, so my base is 10. 10 to what power gives me 10? 1, just 1, all right? Again, this last one a little interesting. We have a fraction inside of there. So we're thinking about 6 to what power gives me 1 over 36, okay? So we got to think a little bit. Could I rewrite 36 with a base of 6? Be 6 to what power? 2. But if it's in the denominator, where did it start beforehand? In the numerator, and what was it? Negative, okay? So my answer is a -2. So if you have a fraction inside your logarithm, you're going to have a negative exponent. Okay. All right, and then those last 4 are just using your buttons on your calculator. Make sure you can find them. Do those for me real quick. This one's common log, and then some log base, just to practice. Notice the instructions here say 4 decimal places. We always do 3 unless we're told otherwise. Okay, so this time it says 4, so we'd want to take those. Y'all do them, and then we'll check them. Are the batteries out on that calculator you picked up first, Sam?
I think so.
What number was it? Number 1. Okay. I'll change the batteries on it. unless I got finger happy when I was typing. Here's what I got. How'd I do? Okay. All right. I was typing those in. That's the lesson. Okay. Didn't feel a need to cram that in with the 3 sections we need to do tomorrow. So just wanted to kind of throw this at you today. All right. Just a little bit of practice. Okay. So today we're going to do worksheet B for 2.9. And there's several problems on here. The last few I really like because they go back and they review some of the stuff from 2, 7, and 8 with composition and inverse. So they're really good problems to look at in the context of a logarithm. So I've got 2, 3, 5, 6, 7, 8, 12, 14, 16, 21. Again, practice what you need to practice, okay? There's even more problems than this on there, so do as much or as little as you feel you need. I'm hoping that felt really familiar, right, from last math class you took, from Algebra 2. Okay? So again, yes, ma'am.
When will our next test be?
Your next test is next Wednesday. Okay. And it'll cover the entirety of Unit 2. Okay. I've been looking at Unit 3, and I think what I'm going to do is 2 tests and like a big quiz. So that's what I'm thinking for Unit 3. And then we'll start review. Okay.
Because the quiz is over 2.0 to 2.6, right?
Yes.
The quiz is basically today.
Yes, 2.1 to 2.6. Yeah. And the next one will be 7 through, I can't remember what, 12, I think. Okay.